Hi Nina, here's a little solution video for numbers 33 and 34 in the chapter 3 of the PPB. So these were problems that the G block were assigned to do for class on Wednesday. So if you could go through these answers with them, or you can also just show them this video if you want. But I think you'll find this pretty straightforward in terms of showing them how these friction problems work. So number 33 reads as a 20 kilogram mass, so I'm going to write mass as m, is pulled to the right with a given force, I'm going to call that force tension, of value 100 newtons. It just barely starts to move. In other words, when there's 100 newtons applied by that force, it's just barely starting to move. In other words, it's overcoming what we're calling static friction, okay, which is given to be 100 newtons. The question asks, what is the value of the coefficient of static friction? So what we would do in this problem is we would look at the first step, which is to complete the free body diagram. So you don't want to really think about the problem at all until you've had a chance to say, okay, I know that there is a weight arrow pointing down, and that there is a normal arrow of equal and opposite length pointing up. So the normal arrow here and the weight arrow here are going to be in a state of equilibrium because there's no acceleration in the vertical dimension. So from there we can say, if I know that the weight is, if I know that the mass is 20 kilograms given in the problem, I'm going to multiply that by 10 newtons per kilogram Earth's gravitational field strength. That's going to give us 200 newtons of weight, which says to us that the normal must also be 200 force because they're in equilibrium. We have all of the forces known and labeled, and so our job here is to sort of just understand what coefficient of friction means. So coefficient of friction, I like to talk to the students about it and say, well, it's basically a measure of how rough or how slippery two surfaces are relative to one another. And basically what the coefficient of friction is like a scaling factor that tells you how much force of friction you get for a given amount of normal force. Okay, so it turns out that the force of friction will increase if the normal force gets larger, basically because the surfaces are stuck together better when the normal is larger. And then the question is, how much friction do you have for a certain amount of normal? And that's what the coefficient of friction tells you. The coefficient of friction, mu sub s in this case, is the ratio of the force of static friction to the normal force. Okay, the kids will recognize this as a variation on what we've been calling the fun formula. F is equal to mu times n, where lowercase f here is friction, mu is the coefficient of friction, and n is the normal. So for this problem, it's simply 100 newtons divided by 200 newtons, or 0.5, and importantly, there is no label. It's dimensionless because it's a ratio of how much friction you get for a certain amount of normal force.